Hey physics students, I'm still in chapter 3. This is Mr. Zentis, and I wanted to get you started on this homework and do one more problem that is relative velocity. Now, just to begin with, don't do the back, so skip the back. Just skip this altogether, if you would please. I'll explain later. The front, however, you can do. And let me get you started with the first one. This is just a projectile. This is just a projectile problem that's fairly straightforward because you're given the velocity, and that's 50 meters per second, and you're given the angle. So I'll just label that as A because this angle is going to change. And what you want to find is this range, or you want to find what we've been calling x. All right. So the first angle, or first A, is 15 degrees. Well, the first thing you have to do, as we've said before, is you've got to resolve that vector. So Vx equals cosine 15 times 50 equals 48.3 meters per second. And then to get the y component, you use sine of 15 times 50 equals 12.9 meters per second. So that's the y component, and the x component is here. We've just resolved that vector. Next, we need to find time, and in order to find time, we're going to get it from this equation. Velocity in the y direction equals acceleration in the y direction times change in time. So, in order to do this, however, we're going to need to rearrange this equation, aren't we? We're going to have to divide both sides by the acceleration. Well, this is change in velocity in the y direction, because as it goes up, it's negative, and as it goes down, it's positive. So it's going to be change in velocity in the y direction equals a negative 12.9 minus 12.9, and that's a negative 25.8 meters per second divided by negative 9.81 meters per second squared, and all that is going to equal to 2.65 meters per second, because that's a velocity. All right. Now, what we need, now that we have, no, it's not. I'm sorry. No, it's not. That's a seconds. Those are seconds. What was I thinking? My apologies. Then, now we have to find velocity. I'm one step ahead of myself, aren't I? Find x. Now this is a distance. X equals velocity in the x direction times time. So the velocity in the x direction we already got, and that's 48.3 meters per second times 2.65 seconds, and that's going to equal 128 meters, and that goes here because that's your first range. That's our first one. And then for height, it's change in y equals 1/2 acceleration in the y direction times t squared. Right? So we have time. However, actually, time. I did it again. There's time. Those are meters. We have time, but that's all the time. We really just want half the time, don't we? So because we want to know what the height is, all of the time would be a problem. So we say 9.81 divided by 2 times 1.3 squared equals 8.3 meters. All right, so that's our height. That goes there. All right. So that'll get you started for the top half of that. Now you just do the same thing for angle. You do the same thing for angle 30, 45, 60, and 75. Everything else is exactly the same. The only thing you change is the angle. All right. Next, what you're meant to do is you're supposed to. We're going on about a flea. A flea can jump a distance of 33 centimeters, 5 jumps northward. This flea. So basically, this flea is going 88 centimeters 88 centimeters in the y direction, and it's going 5 times 33, or 165 centimeters. And what you want to know is this x. This is what you're interested in. All right. So that's what you're interested in. And to get you started, I'd use the inverse of sine change in y over d. This would be d, of course, and that'll give you your angle. Once you get the angle, then you can solve for x using the cosine of the angle times 165, and you should be able to solve for the x that way. All right. All right. That's number 1 in resolving vectors of your homework. Okay. All right. Well, I said that I wanted to talk about relative velocities. How about we try relative velocity on page 105, number 4. Let's give that one a go. We've got a truck, apparently, and I don't know how I'm going to draw this because there's a dog inside this truck, but there's this truck that's going 25 meters per second. So here's the truck, and then apparently there's a dog in here, and this dog at an angle of 35 degrees. It's walking. So here's my dog, and here's the truck. Okay, so, and then there's somebody standing over here. There's somebody apparently standing over here, and this person standing over here is taking a look, and we're interested in this person. His perspective is the one we're interested in. All right. Well, in order to do this, we're going to need to find this northern component. We're going to need to find this northern component of this vector. All right. So once we find this northern component of this vector, we're going to add it to this vector in order to give this person's perspective. That's basically what we're going to do. And because we have the angle, what we can do is we could say cosine of the angle equals adjacent over hypotenuse. And so here's our hypotenuse, and we know this. This is 1.75. That's handy. And so all we have to do is say cosine of 35 times 1.75 meters per second, and that equals 1.43 meters per second. Well, 1.43 happens to be this, 1.43. So now we know the magnitude of these two vectors. All we have to do is add them. So 25 meters per second plus 1.43 meters per second equals 26.4 meters per second, and that's the perspective this person is seeing. The direction would be the direction I didn't resolve, but certainly the magnitude I did, and as you can see, all I did was add these two vectors together, the 25, and then that's the perspective that person was able to see. All right? Relative velocity.